Oh, good morning, good afternoon, and good evening, everyone. Thank you very much for joining us, and welcome to the 8th edition of the Dialogue on Asian Universities. This is a webinar that's been established by Professor Tony Chan, who is currently the president of King Abdullah University of Science and Technology in Saudi Arabia. Myself from the National University of Singapore, and Professor FUNG, formerly Vice President, University of Texas, and also several universities, including University of Macau. And with the able assistance of Max Lu. And today, I think we are delighted to have three very distinguished panel members. Allow me to share the screen and to put the topic under discussion in the proper context. So this evening's webinar is about AI and education, right? And we're going to talk quite a bit about generative AI, which are models that uses neural networks to identify pattern structures and train on the data set. And the word generative means that it can generate new and original content. I guess we have to put original in inverted commas. The power of computing and the algorithm actually enables users to quickly generate new content based on a variety of inputs. And inputs and outputs could include text, images, sounds, animation, 3D models, and many other types of data. So it's really the data structure that you train the neural network on. And of course, we are most familiar with ChatGPT, which was launched late last year, and which caught the whole world by storm, right? And but it's Google's response to ChatGPT, right? And there are also others like Cohere, Generate, maybe less known, but it's very useful in sales and marketing, right? It helps with advertisement. Or Synthesia, which is an AI video creator with lots of AI avatars, voices, and video templates. And DALL-E 2, which is OpenAI's latest iteration of that image and art generation. Oops. Now, with the advent of this ChatGPT, we have noticed that most universities have taken a very proactive approach of embracing or adapting the technology. But they are also very careful in doing that. And many universities have given advisories on how to do that. While we also are aware that some universities have actually banned its use. And what might be useful would be what are some of the considerations from the perspective of teachers and from the perspective of students. And we have done surveys, and it seems that at least I think the initial sort of concern or consideration was whether students will use it to cheat. Right? And of course, there are other considerations that where they become too reliant on the tool. And of course, we also have our professors who ask, how can I use it in my teaching? Right? To help the learning. And of course, there's always the lingering and important question. What will they learn if they use this tool, especially if they use it for a long time? And from the student's perspective, of course, their first concern will be how do I make my handing up of homework easier, sending up and finishing my homework. Some do ask about an appropriate use, right? And there are those that are worried that if they use it, will they be accused of improper use, right? Less, I would say, would be aware that the software actually comes with inherent weakness, and that is of the hallucinations or fake or incorrect data or incorrect outputs. So, important for students to understand if or they know how to check whether the answer is correct. And again, student learning is important here. We also know that AI is going to, the technology is going to cause great disruption. And from the perspective of educational institutions, especially universities, we do need to worry about our graduates. How do we prepare them for work? And how do we prepare our graduates for this technology disruption? So we are very privileged, I think, to have three very distinguished panel members. The first is Professor Teruo FUJII, who is a professor of engineering and microfluidic systems. And he's the president of the University of Tokyo. Our second panelist, it's an expert in the area of AI, particularly in the area of language models. She is Professor Pascal FUNG, the director for the Center for Artificial Intelligence Research. She is a chair professor in the Department of Electronic and Computer Engineering, as well as the Department of Computer Science and Engineering at the Hong Kong University of Science and Technology. And if you look at her CV, she's very decorated. She is a fellow of the Association of Computational Linguistics, also a fellow of the International Speech Communication Association. And they have noted that she has made fundamental contributions to natural language processing and also human-to-computer interactions. She is also a distinguished consultant to Meta. Our third speaker is Professor Manu KAPUR. He is director for the Future Learning Initiative at ETH Zurich. And he is also a professor of learning science and higher education. So if you notice, there are three panelists. One of them leads an institution, top research and education institution. Another one is an expert on AI, particularly on the language processing. And a third is an expert on learning science. So very privileged to have these three wonderful panel members. And I would like to invite each of our panels to share their views in about 5 to 10 minutes. First, I'd like to invite Dr. FUJII from the University of Tokyo. So Dr. FUJII, over to you. Thank you.
Thank you. Thank you so much for the kind introduction, President Tan. And let me share the screen. So first of all, so it is my great pleasure to be a part of this very nice event to discuss on this very important and also interesting topic, which is AI and higher education. And so today I would like to pick up some of the bullet points that we want to discuss in the frame of this higher education in the age of great transformation, so to say, the great transformation by the, we feel like by the emergence of this generative AI, and then we feel like it's a time of a great transformation. And so as a first immediate response to this situation. So this is the quote from my speech of the at the matriculation ceremony, which was held in April. And then, in fact, I quoted a sentence from the Professor President Joseph Aoun's book. So he wrote that is in 2018, around 2018 or 17 or 18. And then he talked about the higher education in the age of artificial intelligence. So then he said that, so he explained that how higher education should be like in the age of this, the advanced AI and robotics technology. And then for the student, it is so important to have some more experience. So this is in the kind of real situation of business or manufacturing or whatever. So the experiential learning in university education is so important as a foundation for nurturing their creativity. That is one thing we also should keep in our mind to think about, to discuss on this higher education in this kind of situation. And so also this slide shows how the students or teachers or professors at the University of Tokyo is embedding generative AI into their classrooms. This is just a couple of examples, but for example, they are basically taking a rather analytical approach to see how this ChatGPT is generating the answers, and then what would be the kind of relevancy of that answers. So that for example, in the first case, so in the group discussion that they make, and then so this discussion should be shared also with the ChatGPT, so they can have a look at their outputs, and then that will make a kind of another, viewpoint besides the students' viewpoints. So, like this way, it can generate a diversity of point of views in a classroom. So that will be like become like a compensation. If, for example, the number of students are so small, then you could make some more, viewpoints, more answers from the diverse viewpoints. And also that is giving a kind of new perspective that students are not aware of. So that is one of the analytical approaches of in the classroom. And also they can even use a ChatGPT to work on their assignments, but they should basically keep all the record, the chat, or keep the conversation with the ChatGPT, so that they could have a look at how they are or the ChatGPT is responding to the questions. So like this way, it is also for students, so important for students to see, for example, what kind of prompting will make what kind of answer or made by a ChatGPT. So like this way, so currently we are rather taking analytical, or let them take analytical approach in the classrooms. And the third point, this is the last one that I wanted to raise, is there's of course fundamental questions that we need to look into as a academic institution. And so far there are quite a few discussions on the kind of a threat made by the AI or robotics. So for example, for me, this book, Mind Children, written by Hans Moravec of CMU, he was talking about the post-biological world. And then that is basically robots or machines somehow are taking over a biological entity, or even share the earth together with the biological entity. So that is one idea. And then, of course, as you know, the singularity is another very big discussion raised. And then now the Jeff Hinton is talking about existential threat. So I mean, for human being. So that I mean, he's rather point out the kind of scary future of the ChatGPT with a very compared to our brain, but very few parameters are like making kind of very good representation of the intelligence. So like this way, still, so there's quite a few discussions that we need to make as and also we need to show to the society that what is exactly is this threat, or what is exactly will become the like issues when you face such kind of a very big transformation. And so this is just a summary, but besides this interesting topic, we also can think about, for example, like so science acceleration by this generative AI or machine learning itself. And also we need to discuss on the energy issues. And of course, when you think about the future of our work, and then some more efficient or more productive use of this generative AI should be also discussed. And then also the language. So this is a large-scale language model, so that we also there might be some concern about, for example, equitable development or access to the language model based on the specific I mean language that is not that many people are, for example, speaking or using. And like on the other side, if we could use this kind of technology to prevent the native languages from extinction. So that is the kind of very brief overview of what I wanted to discuss here. Thank you so much. Oh,
thank you very much, Prof. Fuji. I particularly like your point on this accelerator size, because it reminds me of this AlphaFold, which I believe was done by DeepMind, and that actually helps with protein folding, and the algorithm just allow biologists to actually do protein folding much easily now, right? And that has accelerated a lot of biomedical sciences. Next, I'd like to invite Professor Pascal Fung to share her presentation. Can you unshare, Prof. Fuji? Thanks.
Sorry, I was muted. Can you see my slides? Yes. Okay. So hi. I'm Pascal Fung. I'm also a visiting professor at the Central Academy of Fine Art in Beijing, and I was a former distinguished consultant for Meta. So today in my talk, let me just first by again going over what generative AI is briefly. Why is such a big deal? So large language models, people have been working on this for quite a few number of years. Actually, preceding GPT-3, there was GPT-2, GPT-3, preceding ChatGPT, I mean. And of course, Google had Lambda way before, and then Meta also had other kind of generative AI conveyor systems such as BlenderBot and other large language models preceding ChatGPT. What made ChatGPT really viral was because OpenAI incorporated this conversational interface, so people can actually chat with the underlying large language models in the conversational way. So before that, we have generative conversational AI systems on one hand, and these large language models on the other hand. And you cannot really interact with large language models via conversation. So ChatGPT sort of did this both, and then it became very easy for the public to access the amazing capabilities of the large language model GPT-3, 3.5 via a chat interface. So that actually made it viral. But I think the most important thing is that these models, I should say, there's another class of generating models called diffusion models. They are similarly creative, and people use them to generate images. And these models seem to have learned the laws of physics in the way they can generate images with that obey laws of physics. And I think the most distinguished characteristic of these generative AI models is that they were not trained to do what they're doing. So before then, we would train a system to do machine translation, or a system to do conversational AI, or a system to do task-oriented dialogue completion, or a system to do computer vision, recognition for faces. And these systems would do what we train them to do. But with these generative models, they were only trained in a self-learning way. They trained from all the data on the internet, and they learn. The objective function of this training was just for them to predict the next word or to generate an image from noise. But somehow they are able to have all these capabilities, cognitive capabilities that they were not specifically trained for. And I would say that even though we have done a lot of benchmarking on ChatGPT and others, I don't think anybody today can say that we know the full scope of their capabilities today and even tomorrow. So we do not know. They seem to be this kind of model that we discovered, not just like something we made, but it's something we discovered. I think this is why it is so exciting at the same time as kind of scary, right? Because usually people say, people trust the experts to know what we built. But today, as experts, we can tell you, we don't really know the full scope of these models' capabilities. This is why, and there are currently two views of generative AI, the utopian and dystopian. People who believe that AI are powerful assistants to humans, especially they can solve the labor shortage for the aging society. And according to official surveys, the trusting technology in AI and experts usually is higher in Asian societies, and especially Confucian societies. Whereas in the European societies, there's this kind of view of existential risk, that they are threats to humans, they replace jobs. And usually these are societies where people in general have kind of low trust in the government, and leading to even low trust in experts, which we have seen very different approaches, for example, to the COVID crisis that was shown, that have manifested these two views, especially on experts and governments. So unfortunately, that also brought this kind of dystopian view on AI. Now, of course, neither side is completely right, and there's a need for us to learn from these two perspectives and to have a cautious optimism about using AI and to prevent, to mitigate the risk. And I will also say that why people think there's existential risk. I think today AI has reached this uncanny valley where if you interact with ChatGPT, you will see the responses almost human-like. And as human beings, we have this evolutionary instinct, a reflex to fear things are almost human-like, but not quite. So for example, we have this fear of zombies or dead-looking animated images, even in movies. And this kind of uncanny valley, psychological fear of the uncanny valley is well known. And I think that applies to how people feel when they interact with GPT-4 and ChatGPT. So, but this existential threat, to me, it is much less than the existential threat today of climate change. All right, so I was in Italy last week. We experienced the hottest week in human history. And if this goes on, I don't know where we're gonna go. So I think there are a lot of existential threats brought by human beings. And perhaps we can use AI to help us solve those problems, right? And then, before I even continue, I want to alert to everyone that all the images in my slides are generated by Midjourney. So this is the first time I have a slide that's completely generated. The images are generated. Of course, the content is done by me. So this is a very good example of human-machine interaction. And I don't think I could ever draw some image like this myself. So I'm very happy to be using Midjourney. So for the first time, we actually encounter some intelligence, right? It seems alien, but this alien intelligence is comparable to ours in terms of past performance. I would say in terms of past performance, okay? But they do not manifest any intelligence without being prompted by humans. And in the future, even now, we have to live in a symbiotic way. We have to learn how to use them. And many skills in the future, cognitive skills, will be replaced by machines. Look at my slides, right? All the images, instead of downloading images from the internet and pay for like getting images, I generated these images using prompts. So this is a skill that's replaced by machines. I want to emphasize these are skills. So we need to understand what skills machines have. And we need to go back to teaching humans the basics, how to be human, how to be more human. So I would say the basics of STEM, such as scientific thinking, scientific methods, mathematics. I mean, these kind of subjects need to be taught to even humanities students. We need to break down the silos between STEM and humanities. And to the engineers and the scientists, we need to teach more interdisciplinary knowledge. For example, also the fundamentals of humanities, such as philosophy, such as critical thinking, such as creative thinking. All right, and we basically need to break down these silos. I teach my students, the design students in CAFA, the Central Academy of Fine Art, some computer science, so they understand what can be done by Midjourney, what cannot be done. I need to teach them a little bit of the know-how of what generative AI can and cannot do. And I teach my PhD students a lot of this, AI ethics and the way of thinking of the philosophical thinking of AI modeling. Because I tell them that, when you're getting a PhD, it is a doctorate of philosophy. So unfortunately today, many of our engineering PhDs do not have any background in philosophy. So they have not learned how to think deeply about the implications of what we do, which is sorely needed. We can no longer say, okay, engineers build the models and the philosophers worry about the risk. It does not work that way. We have to work together. So if we want to work together, then we need to teach the future generation of our AI workers. Everybody is going to be either building or using AI. So these are the fundamentals I think we need to teach and go back to the basics. I know my view is probably a bit more controversial, maybe against the mainstream. I think a lot of people are saying we need to teach kids programming skills and even prompt engineering skills. And I'm telling you, these skills will be replaced. Humans won't need to do programming anymore. I've been saying this for a decade. Even today's programming, it has nothing to do with the kind of programming I learned, even less to do with the kind of programming that people did in the 60s. So in the future, this kind of programming skills will be replaced. And also, I don't know what people call prompt engineering. It's really just using how to prompt. And I think today, how to come up with better prompt has a lot to do with your humanities background. So I would say like writers and social scientists, psychologists especially, would come up with better prompt than engineers. But unfortunately, they also, since they do not understand what machines can do, they cannot have good prompts that will speak the language of the machine. So integrating the two skills, like knowing how to be a better human and knowing how machines work, will lead to better prompt engineering of the future. So I think that's all. That's my message today, and I'll be happy to answer a lot of other questions.
Thank you very much, Professor Fung. I think I love your pictures, the pictures that you have generated using AI. It sort of helped you articulate 2 points, right? One, that AI can actually help and complement. And then second, that AI can also displace jobs, amongst other things. I'll definitely come back to you with some questions. Next, can I invite Prof. Kapur to make his presentations? Over to you, please.
Sure.
Thanks.
Hang on just a second. Sorry. Something happened. Can you see my screen? Wait, let me try again. Okay.
Yes, you can put it in presentation mode.
Yep, got it. Yeah, okay, thank you. Thank you, Prof. Tan, and thank you all the other panelists as well, Teruo and Pascal. I enjoyed your presentation and lovely to be part of this panel. Pascal, you'd be happy to know that I am one of your interdisciplinary scientists. I'm an engineer turned statistician turned social scientist. And at ETH Zurich, where I direct the Future Learning Initiative and the PhD programs in learning sciences, we intentionally take STEM students, masters in STEM students, and give them PhDs and train them in the social sciences, in the learning sciences, so that they become interdisciplinary PhDs, having expertise in both the domains. So that is happening now already, and I completely agree with you that we need to do more of that. All right, so thank you for that thought. What I'm going to do today is just make basically 3 points from a learning sciences standpoint. So I study the fundamental processes of human cognition and learning from the physiological, neural, cognitive, affective, and social levels. And I want to bring some of our thinking and findings to the conversation that we are having here today. So the first thing I'm going to talk about is the language part of the large language models. Why is language so central? And I think philosophically and epistemologically, language is central to cognition. This is how we build culture, which is why Harari, he had this quote saying, "You hack language, you hack culture." And this is why it's different from information. It creates a connection, it creates an intimacy and that's why the personalization aspects of large language models are so uncanny. You feel connected to them. And so there is, on the one side, there's personalization of the learning experience is being hailed as the holy grail that we can now achieve. But there's also a double-edged sword, and I just wanted to talk a little bit about that. So the promise of personalization is, okay, we can design learning environments based on these large language models that can personalize to the learner's needs, right? And you can have the personalization vector that has multiple variables, and you can personalize to all of them if you like, right? The problem with that is that if our learners, if our students, their entire learning experiences are highly personalized, they will never learn to be adaptive, because everything is organized or personalized to them. When will they learn adaptivity? So I think we will lose out developing adaptivity skills if we go into hyper-personalization mode. A second point on personalization where we have to be very careful is the vectors we want to personalize to. So for example, do we personalize to a student's preferred learning style, for example? And the answer is no. Actually, science is very clear that matching learning to the learning style never gives you any effect on learning. Yet it is a multi-billion-dollar industry based on utter rubbish science, right? So the idea that there are some variables that you want to build personalization on, other variables you just want to ignore. Attention is another one of them. If we give in to the attentional preferences of students, then we only perpetuate the negative loop that, their attention spans become smaller and smaller and smaller. So that to say that personalization on some variables is good, like, for example, prior knowledge, their knowledge state of the learner. So if you can map the knowledge state of the learner and then you personalize based on that, that's a good thing. If you personalize on the affective state, that's also a very good thing. Biofeedback could also be a very good thing, but there are certain things you just simply should not personalize on. So I want to talk both about the promise and the perils of personalization. The promise is in the judicious, scientifically sound use, and the peril is in the hyper use of personalization. But at its core, it's language, and that's why we can personalize. My second point is about expertise. And when we study experts, especially adaptive experts, here's a simple figure. We obviously know that experts know a lot of stuff,
right? They have a lot of knowledge, they have a lot of experience. And broadly speaking, you can divide this into two, explicit knowledge and tacit knowledge. Explicit knowledge in a domain is the stuff that people can talk about, they can write. These are the constructs, the grammars, the rules. You can write books on it, you can give lectures on it. It can be made explicit, it can be externalized, it can be represented, right? And tacit knowledge is this other kind of thing that people have, but they can't externalize it. It comes out in disciplinary activity. It's situational. Even experts, when asked, how did you think about this idea? Or why did you do this in this situation? I don't know. I just did, right? And true expertise is this, not just explicit knowledge, it's the coupling between the explicit and the tacit, right? So, and this is a slide I've been using for many years, and my point has always been, if the focus of our teaching and learning or educational experience is on explicit knowledge, well, explicit knowledge can be codified. And if it can be codified, it will be automated, right? And so as teachers, as institutions, as designers of learning experiences, we have to perhaps move away from explicit knowledge as the focus to coupling the tacit with the explicit, which I was glad to hear Teruo already pointed out. The experiential nature of learning has to come to the core, which kind of sits nicely with perhaps what Pascal was saying about the human aspects of learning, right? And we find that this coupling between the tacit and explicit comes out very nicely in disciplinary practice. So the idea here is you're not just learning about mathematics, which is explicit knowledge. You're learning how to be like a mathematician. You're not just learning about engineering, you're learning how to be like an engineer. Again, the burdens you take on designing the learning when you shift from learning about to learning to be is the burden you're taking to go from explicit to the coupling between tacit and explicit. And that's what we need to redesign our higher education. In fact, I would say not just higher education, this has to start from the very young, right? So that's one major interesting. And this, if we continue down the track that we do, then I think we may be disrupted radically. So we need to have this coupling back into the core. The second point I want to make is about learn agility. You can learn a lot of content knowledge, you can learn a lot of skills, but one of the key things that you have to learn is learning how to learn something new. And not just something new, but something that is hard, right? And something you need to do quickly. You don't have time to go back to a course or continuing education program. You've got to do it quickly by yourself using all the tools and resources, including generative AI. So an implication for higher education and education in general is, to what extent are we giving students or designing opportunities for students to learn how to learn? Right? And to what extent are we assessing these capabilities as well? So at Zurich, we're designing these into the learning experiences, and we're also designing psychometrically valid ways in which we can assess these skills in a summative environment as well. Okay, and that's something that these are the two implications that I would say first come up in my program, especially. Right, so that's language and expertise. And then I'm going to talk a little bit about the challenges. First, there are three challenges that I focus on. One is bias amplification, ethics and regulation, and over-reliance. Bias amplification is simply the idea that if you're training models on data set, then bias is inherent because data is inherently biased in one way or the other. Amplification occurs if, and Pascal would probably be the better person to talk about it, but I'm just going out here. If the output data becomes also the inputs, if there are feedback loops in the training, then whatever inherent biases are in the data set can be amplified over time. Or if there are skewed representations, we're talking here on a dialogue on Asian universities, to what extent these large language models are trained on English data sets and other data sets, what kinds of profiles are represented, overrepresented, underrepresented. These all biases can be amplified over time if we do not do any either ethical or regulatory stance on it. I think the ethical issues are straightforward. I've already covered them in bias amplification. And the third point is on over-reliance. I think we don't want these tools to become crutches. You want them to use, we want to learn how to use these tools. Our students, our children need to learn how to use these tools, but to use them in ways that they can be productive, in ways that humans and machines can work together, but not to over rely on it. So the need for the basic fundamental grounding is strong, but we need to design that grounding in ways that are now consistent with theories of expertise and learning. So I'll stop there with this summary of the 3 points that I've made. So thank you very much once again for giving me this opportunity to share. I'm looking forward to questions and discussion.
Well, thank you very much, Prof. Kapur. From now on, if the panel members don't mind, I would go on first name basis.
I already did.
Much easier.
Sorry.
All right. I already noticed that there are quite a lot of questions, and we are actually way past 45 minutes. So I would like actually to, because as I go through your 3 presentations, I noticed that Pascal, you may have missed out one particular slide. Can I invite you to say, because I think that slide is important, could I invite you to show that slide again and sort of share that with the participants? Thanks. You're on mute.
Well, human skills are not perfect. So I clicked too quickly and then skipped over this slide. So in this slide, I want to highlight what I think as the major differences between machine intelligence and human intelligence, and which led to my proposal of what we should teach humans to be more human. Let's talk about human intelligence first. I think a lot of our, Manu just mentioned about this 2 different kinds of skills. And I think some other scientists will call them system 1, system 2 thinking. And I think a lot of the human intelligence came from evolutionary need for survival. We have this survival instinct. And there are a lot of things that we instinctively have this reflective reaction, and we try to learn, for example, to prevent danger. And that is, our evolutionary instinct. And a lot of human intelligence is also introspective, and we have what people call conscientiousness. For example, if I stay in the cave for 40 days with no interaction with any other human beings or social media or anything, I will still have a very rich internal world, right? I'll be thinking, or I have my own internal world. On the other hand, if you look at machines, if you do not have humans prompt these models, there's nothing. They're not doing anything. There's no thinking or reflection and so on. And humans are learning from both the abstract world, not just the online data, the abstract world, the writing and so on, or the images, but we also learn from the physical world. That is very clear since we were babies. Even animals do that. Machines today are not yet learning from the physical world. When we embed AI into robotics, we'll be interested to see how embodiment will enable machines to learn from the physical world, but not yet. And also machines today outperform the average humans on many cognitive tasks, emphasizing performance and tasks, all right? It says nothing about the internal capability of these machines per se. So there are linguists who talk about meta-linguistic questions about these large language models, and we don't have the answers for, because every time you ask these models, are you intelligent? Do you have self-consciousness? Do you know what language is? It will always give you the answer to the best of its ability, meaning whatever answer it has learned from the data, it has nothing to do with what it really truly is. I think this is very important. So if you ask the machine some questions about anything, about me, about anything in the world, it will give you the best answer it can have, but it doesn't have to be true. All right, there's no sort of self-reflection on the answers it's giving, even about itself, its inner workings. So if we ask questions about large language models, 2 large language models, its answers may or may not be correct. Okay, so this we need to be very clear. It's a performing some tasks, including the task of answering any questions you ask. Okay, and also because these machines are trained from everything under the sun, there is no coherent value system. OpenAI has incorporated human in the loop, and many other companies are trying to do the same in order to give these machines sort of alignment with human values. Otherwise, the raw language models have no consistent human values. I remember when we demonstrated our one of the first generative comp AI systems back in 2019, the backbone of that system was GPT-2, and we fine-tuned it. If you ask that chatbot at the time, are men superior to women? It would say, yeah, men are superior to women in this and that ways. But if you ask the chatbot, are women superior to men? It will also give the answer why women are superior to men. So that's what I mean by machines do not have a coherent value system. On the other hand, of any human being, unless they're schizophrenic or have other conditions, then we have learned through our life experiences, our lifelong learning, somewhat coherent value system. And also, humans, we cannot be experts in many areas. We cannot even be a expert in one single area. Okay, I cannot be, so we call ourselves experts, but not a single human being really knows everything about a single domain, whereas machines can be trained to be experts in many different areas. And but today, machine intelligence has reached the uncanny valley of seemingly close to a human being. So I think it's very important to understand the difference between these two kinds of intelligence when we're talking about what we can and cannot use. And in my classes, so as I say, I teach my PhD students to use ChatGPT or GPT-4 to polish their publications. Whereas the ideas of these publications, of course, have to come from them. I myself don't use these writing tools because I like to control my own writing style. And I find the writing tools give you a kind of writing that's kind of bland and kind of average. And there's no flair in the way it writes. Unless you prompt it, you can prompt this writing tools to give you some kind of flair. So that's also very interesting. Other than that, I teach design students to use tools like Midjourney or Stable Diffusion to come up with various kinds of ideas for ideation. It is very, very good to help them to have sort of a brainstorming session. But at the end of the day, it's the designers and the artists who have to curate or prompt these machines to have better images. So that's what I want to emphasize between these two kinds of intelligence. Thank you.
Well, thank you very much, Pascal. In fact, we can actually draw, similarities, across different contexts. So Teruo was talking about experiential learning versus, I guess, the normal academic learning. Pascal, you're talking about human intelligence versus machine intelligence, all right, in your context of AI. And Manu was talking about learning to be, all right, I like your tacit knowledge versus the explicit knowledge, and needing actually to have that coupling. All right, same thing. I guess experiential learning is actually to couple to do with to know. All right, and coupling the human intelligence with the machine intelligence is the collaboration that Pascal spoke about. Now, I noticed that there are quite a lot of questions already, and if the panel members allowed me, we can actually go and address the questions directly. Can I also suggest that all panel members, you unmute yourself so that you can jump in and answer the questions. All right. So the very first question is from Muhammad Baisa. And he said that, well, in my opinion, exams should emulate daily life challenges. I agree with that. In daily life, we often refer to several sources, including internet and now ChatGPT. Should all exams be open book? right? And marks be awarded for maturity of thought processes rather than accuracy of the answer. Many things in real life is about application of knowledge rather than regurgitation of knowledge. I think generally we would agree with many of the things you say. On the question of should all exams be open book, I think I'll pause a little bit, but I'll let my panel members comment.
Maybe I can jump in here.
Yes, Manu.
Yeah, so I think the one way that we're thinking about this question is, how do we design exams which are resource rich? You know, so we have a system of examination in many parts of the world where a child sits in a strange room with other people in rows and columns without any tools or resources other than their own knowledge, and sits for 2 to 3 hours to answer some contrived questions. Now, that is ecologically rather invalid, an ecologically invalid measure of learning, right? So yes, we do need to push towards assessing learning capabilities in ways that are ecologically more valid. And if you look at humans in the wild or in the workplace, in our lives, we are tool users. We build tools and we use tools to adapt either to the environment or adapt the environment to us, right? So we need to do both. How do we do that in a systematic, psychometrically valid way? That's a very big challenge. And so I don't think the answer would be in making everything open, but I think the answer would be in trying it in a multi-dimensional way to tackle different aspects of what a capability looks like, and not over-rely on this one very strange, contrived setting that we often use.
Yeah. Thank you very much. I do share the same views. Pascal, please.
Yeah, so I want to follow up. I really like Manu's point about learning to be versus learning about, and I think there's a need for both, but at different stages of a student. So I'm also a mother to 2 daughters, and I'm very strong advocate of teaching younger students learning to be, and then teaching older students perhaps additionally still learning to learn, learning to be, but additionally learning about. What do I mean by that? So I use analogy of these large language models. Okay, so these large language models are basically taught to be. Okay, they were taught to predict the next word, that's it. But in learning to be, they learn how to perform certain skills. So in humans, what do I mean by that? I've always advocated that it's important to have language, literature education, and mathematics education. So when they become older, you can pretty much tell whether somebody has logical thinking, whether they were good in math when they were young. Okay, and if somebody has philosophical thinking or creative thinking, is closely linked to whether they had good language education when they were young. All right. So what do I mean by that? I think that human brain is trained by mathematics and the language to think in certain ways. Our brains are wired in certain ways, and we need to learn languages very well when we were young, and we need to learn mathematics to some extent when we were young in order to grow up to have the capability of further logical thinking, analytical thinking, critical thinking, and so on. So in Hong Kong, for example, I always find this problematic, which is that in our younger students, right, our language, so most of the population speaks Cantonese, which is not a written language. And our written Chinese is closely related to Mandarin. But, we didn't teach these kids Mandarin when they were young. So they were taught in Cantonese, this strange foreign language, which is standard written Chinese. It's like teaching French kids Latin, right? And then, so I think we have we have for the longest time a very deficient language skill, linguistic education in our system. And also in many kids who didn't choose science stream, they were not taught mathematics. So, we have kids who are super good in mathematics. I think in Asia, we have a lot of Asian kids who are super good in mathematics. But these kids are not necessarily taught very good language skills. So learning to be is what we need to teach the younger kids, and learning to learn and learning to about is some skills we have to teach them later on. So that will answer one of the audience questions about how can we include the needs of companies into teaching. I think that would be later on, but we need to really reinforce the learning to be and the learning to learn part of the teaching.
Yeah, I think this
So
is also,
exams,
yeah.
So
This
exams
also
need
the
to tailor
coupling.
towards that.
The coupling which Manu speaks about, right? I mean, learning is not a single modal. All right. In fact, there are many different pathways. But you need to learn a sort of core knowledge, and you need to learn, all right, the other sort of tacit knowledge or skills that goes along with it. And if you have too much of one, then you need to complement with the other one. And vice
May I
versa.
clarify the nature of this just a little bit? Yeah.
Sure.
So the point about how we encode information is that we are encoding both the context and the content. So if you're learning about mathematics, listening to a lecture, you are learning mathematics you're encoding the entire activity itself, so that if the activity changes to problem solving or invention or creativity, the same content does not have paths to use it. Right. And I think it's happening. Learning about and learning to be are happening at the same time. We just need to be careful that the about is situated in the be that is actually good and not that one that is not useful. Right.
Yeah. Okay.
So
Thanks.
I just
yes,
wanted to
Teruo.
say one thing. So it's in this context, I myself is I think it's so important to think about the ability to pose a question. So in this case, so the ability to pose a question is very much related to learning how to learn. So that in this context, with internet or chat GPT, then so how to make a kind of right prompting would be, or right keyword for search, it would be very important in a practical situation. So and then overall, it's so important for us to teach how to pose a question, or train them to pose a good questions.
Yeah, thanks. I also would like to suggest to panel members that we do have many questions, and we want to be more succinct with our answers to the questions, so that at least we can try to answer many more. All right. If I go down the list, what are the most serious issues using AI tools that face teachers? So this is from a teacher's perspective. Well, one of them, for instance, if I may start, right? I'm reminded of this Wall-E movie. That was a Pixar movie that probably about 15 years ago. It is a cartoon, and it's about humans and machines. And the thing that sort of struck me at that time was that the humans were all obese, all right? They were in a spaceship because of microgravity, and also because the machines does everything for them. So they don't even have to walk. They just have to eat. And they became all obese. They lose their ability to walk, all right? And of course, they're just floating around. And you see, that I guess is, if you look at too much dependence on AI tools, all right, then I think there are some basic foundational skills or abilities that you may lose, all right? It's like giving a calculator to a kid before you teach the kid arithmetic, how to add, how to multiply, but just teach him how to use the calculator. Then I think the kid loses a lot of the foundational knowledge that are quite essential for building knowledge and understanding later on. Please feel free to jump in at any point.
I see a question. Can I ask that question? Somebody asked me, humans tend to have a tendency to adopt a self-destructive path. So how
yes, please go ahead.
How can we prevent AI from taking over us? I think the risk of AI is real. It's not as exaggerated as some leads us to believe, but it is real, because it is a very, very powerful cognitive tool, not just a physical tool. It's a cognitive tool. and it can lead to many misuse by bad human agents, and so on. So I think the risk is really as a tool that amplify human bad agents. AI itself does not have, you know, this instinct to take over humans. As I said, machines are not like humans, so they don't have this evolutionary need to take over others or to be to take over the territory or the power from others. They don't have that intention unless we, you know, make them to have that intention, right? Currently, we don't have that. So, but if that's something like that happens, it's because some humans try to make machines do bad things. So I think there we need to have very strong regulations against misuse of AI. And that is about the human society, that's about regulation against misuse. And that is, so there are a lot of international bodies, standards bodies that are actively working on this regulations, and I'm part of some of them. And it's by no means clear what kind of regulations we're gonna have. In particular, we cannot have over-regulation that's catered towards the current state of art of the technology. Then these regulations will be obsolete very quickly. And we also cannot under-regulate. If we under-regulate, then these regulations are not meaningful. So what I think we should do, as have been demonstrated by a lot of existing regulation, is that you know, for example, in the medical domain and the financial domain, and legal domain, there are already very strong regulations against fraud, against misappropriation, against misuse, and so on. So whether you're using AI or any other tool, you must comply with those existing industry regulations. I think that can be applied to many other cases. For example, in education sector, we have obviously my university as well as many others have very strong rules against plagiarism. So if you copy somebody else's content without citation, then it's plagiarism. So that applies to using AI tools to plagiarize as well, right? So it doesn't have to go to the underlying technology, whether you use AI or not. And on the other hand, you know, we can use spell check, and we can certainly use ChatGPT to polish our writing, and that is not considered cheating in our university or anywhere else. So I think there are existing regulations that guards against misuse and bad agents, and we should really refer to those existing regulations more when we look at AI.
Yeah. If I can quickly jump in, and I think that that's a question on also who should be the regulator, or who should provide the regulations.
That is the really important issue. So especially for the, I'm just, I'd like to jump into the also the Pascal's discussion. So the regulation should be also, especially, I mean, carefully be discussed if it's, I mean, concerned about the like a plug-in to the hardware control of the, I mean, of AI. So then currently there are not many, I mean, things are done by all these generative AI, but all these, I mean, non-physical, but mostly. But if it comes over to coming out to the physical world, and it will make a kind of so many different concerns around. So that is the really a kind of careful the points that we need to be careful for, and also who's regulating that, and it is I mean, already we need to think about when we, for example, maybe the personalization itself will be not much, I mean, will make not much concern, but like if you, for example, use this generative AI model as like in a commercial companies or whatever, or academic institutions, and then this basic model should be basically tuned, right, in time, and then but you will need to verify that this model is like basically trained in the right direction, and then who's doing such kind of verification. That is a really important issue. And at some point, maybe the AI itself can do that, but at some point you will need to, I mean, so this will need to be grounded into the human intelligence. So yeah, that this
Right.
might be also make this will make a kind of very big discussion.
Yeah,
And
thanks.
very quickly, there are also issues around, how you train data sets. I think regulations have to come in there, protecting privacy and surveillance, transparency. We don't know how these things work, so explainable AI movements are really important as well. So I think there are a number of things that go into this ethical regulatory framework that we need to think about.
Yeah, I would say that regulations can be tricky if you want to apply across the board, because AI tools are actually applicable to all disciplines, right? In every area of life, eventually, right? And the context is very important. And so I think you really need, at the micro level, the key stakeholders to be able to frame the sort of regulations. Like, for instance, Pascal mentioned that universities, where integrity is very important, and it is important that you don't plagiarize another person's created work. All right, so that is one aspect that universities, they put a stop to it. All right, at least a warning sign. Likewise, journals, right? You see a lot of the top journals that come out with advisory on when to use ChatGPT or AI tools and why not to, and then how you must declare it, and so on and so forth. All right. So I think regulations are going to start bottling, coming from the various sort of fields and various specialties. And I guess the government can probably put an overarching one, but you have to be careful, because if you put one that's too tough, then you can stifle AI. You put one that's too lax, then other disciplines depend on it, then you get a lot of problems. So there has to be a delicate balance, and I think we will find the right balance as we go along. Okay, let's answer some other interesting questions. I think there's a question on asking Manu to elaborate on learnagility.
Okay, so like I said, learnagility is the idea that we need to formally design opportunities and assess these capabilities for people to learn new things that are hard, that they need to learn by themselves using all the resources they can muster in the environment, and learn it quickly, because timeliness is of paramount importance. If you look at this as an analytical tool to look at how we design the learning experience, when do students get the opportunity to learn something new on their own, in a timely manner, in a resourceful manner, and something that is hard? Almost never. Everything is curated for them from the get-go, and because as educators we feel we need to do that, but I think we may be doing more harm than that. And it's a very recent program of research. We are just about a couple of years into it, and so if you're interested to learn more about how we're thinking about it, how we're designing for it, and how we want to assess it, then please feel free to contact me outside of this, because I don't think we have the time to go fully into this area. But broadly speaking, it's a very important thing to consider. And ChatGPT and generative models just came out, even making the argument for it even stronger. Yeah.
The next question, which I like the panel members to look at, it's a very interesting question that I think is often asked. And since all four of us are professors, this is the question. In the future, is it possible that teachers like us gradually be replaced or weakened by AI? If they are replaced, should teachers do research instead of teaching? Since teaching and learning help each other, AI may cause the mechanization of education. Then how to avoid this situation? Any response?
I have a quick answer. If the teaching and the design of teaching continues to focus on explicit knowledge, we will get replaced. And I think I should say we should get replaced, because that underdetermines what we can offer from a humanistic standpoint to the students, right? So that's my short answer.
Great answer. Any response?
But I think I think that's
Yeah.
it depends. So it's based on the answer based on the today's discussion. Then I think all this, I mean, the research work and the teaching is basically coupled, and then all this, as we talked about experiential learning, then that is, I mean, definitely indispensable. The like a research part. So that so teachers should, I mean, do some research works in terms of this higher at the higher education level.
Mhm. I think
My view
that-
might be a bit because to me AI is not that good. I mean, it can perform many tasks surpassing humans, but it also can be very naive in other ways. Its mathematical skills are not completely, it can do very complex problems, but then it would sometimes make mistakes even counting. So I don't know, why would I rely on AI as a teacher? That is not very fathomable to me. But perhaps in the future, we will have AI teachers teaching us language skills or teaching basic mathematics. For example, we already have interactive tools online for language learning and in other kinds of learning, but they are still not like humans, right? I think psycholinguists had done studies where they show that children, to learn a language, they cannot even learn from the screen, like from the same instructor who teaches children from a screen, like via a TV or some other screen, and the same instructor doing that in live, interacting with the students. It's totally different, meaning kids can only learn from real interaction with humans. So that's why in our evolutionary in our evolution, right? Even animals learn from their parents, whatever. So I think that side we will always need human teachers, and but some skills can be taught by machines, and why not? Then that will free up the teachers to teach more how to be and how to learn. So I think humans can never replace. Can parents be replaced by machines? Of course not. To me, that's not even a question. So
Yeah, thanks, Pascal. I would just say that I thought that all this advent of AI tools is really a good opportunity for us professors, all right, to really reimagine how we teach. Many of our professors still are teaching in the way pre-AI, right? Even though our students are actually very different, we are still teaching in the way that we were taught 40, 50 years ago, right? And I think this is a good chance for us to rethink, because we have actually been teaching explicit knowledge, right? And I agree with Manu that the more we actually just focus on explicit knowledge, we're going to be replaced, right? I think this is the time that all of us should be reimagining how we teach, all right? And this will be important. And here, I think there's one question about, are there, so we have many passionate teachers here too. Are there any resources that give guidance to educators on how to teach students learn how to learn, and also how to access this? Responses?
So, I mean, resources-wise, I think the research on learning to learn is rather new, but there are resources on how to learn, just how to learn. What are some of the models that are very good for learning? And especially in the past 20 years, we've broken away from the past models of direct instruction. So we have models like productive failure, failure-based learning, and so on and so forth. And the papers are out there. Yeah, so I think you just have to search for it. But the resources they're not in any curated manner present and available.
I do think that these are usually also available within many universities. So in NUS, we have a Center for Development of Teaching and Learning. I have many passionate teachers, and they may teach in their different ways for different subjects, but they are always happy to share all right, how they teach students on how to learn, all right, what are the learning outcomes expected of each courses. And I see that actually present in many universities. So to be able to get into that learning community or that teachers community as somewhere I would say you can readily learn from real practitioners who are always experimenting on new ways of doing things. All right.
And then, sorry, there's also a community that looks at scholarship of teaching and learning. So I think that's also a good community to look into, I think.
Yep, and you can Google that. That's actually
yeah.
quite a lot written on scholarship of teaching and learning.
Subtle,
in fact,
yeah.
many books have been published on
Yeah.
the scholarship of teaching and learning.
Yeah.
All right. My friend Feng Daxian gave a tricky question here. If AI were around in the beginning of the 20th century, will it develop quantum mechanics, which has completely changed humanities? Anyone? My answer is, I don't think so. Because the AI that I see now is really not based on deductive reasoning. All right, it's very much similar to what Pascal has mentioned, that it can still not add properly or do arithmetic properly, right? Because it depends on really if it has seen this sort of examples in text, in languages. So, but I think if in time to come, AI would be able to do deductive reasoning. That's a few more steps up the intelligence sort of hierarchy. And that's when I think probably that might happen. But at this stage, I don't think so.
So let me jump in, okay? Like when we talk about AI, today we talk about generative AI, in particular these foundational models like LLM. These models were trained to be generous models, so they have many skills. But there are specifically task-specific AI models that were trained to pass exams, for example, mathematics exams, and to pass language exams and so on. So there are AI systems that are trained to do many skills at a human level, or even bypassing human level. But doesn't mean that generative AI, I don't know, we're talking about generative AI a lot today, but there are many applications today people are using non-generative AI. So classification, content moderation, machine translation, not necessarily, well, machine translation is now generative AI based, but otherwise, facial recognition at the Singapore airport and Hong Kong airport, they're not based on generative AI. You don't need generative AI. So I think there will continue to be tools developed for specific tasks using generative AI or not. And then you have this kind of generic generalist AI tools. I do not want to say they are artificial general intelligence. They're just kind of multi-domain, multitask AI tools that can be used to specific tasks. So I would say, you can use either. And then in terms of deductive versus inductive, today these generative models are better in deductive rather than inductive tasks. Meaning that if you in your prompt you give it all the background of the questions you're asking, it will give you the right answer. But if you in your prompt you're asking a question that will rely on external knowledge or prior knowledge, it might or might not give you the right answer. So the way to do it going forward, so we're working on research to make these generative models to have to actually access external knowledge sources. So there are many different ways of doing this. It's not one model. It's not like one model is the entire AI. So there are still many, many different kinds of AI being used today, and there will continue to be many different kinds.
Thank you. Can we move on to one of this question here? Right. This is I guess trying to bring that AI applications down or upstream, and perhaps I think the panel members have some suggestions. So how to effectively implement AI from secondary level especially in science and math subjects, so that students from the beginning have good experience and knowledge on how to utilize AI skills. While I think he's mindful that excessive utilization can also make the addiction of it, which is highly dangerous. So I guess he's talking about how to balance it. So this is a question by Asan. How to bring it up that to the earlier the younger students, the secondary students.
But I think so. This is one of the directions that the AI can be, especially all these conversational type, as AI with a conversational type interface should be applied. And also, as Manu talked about, all these in a personalized way. So that makes it like quite, carefully tuned learning. Could be a carefully tuned learning method to, adaptively tuned method for the individual. So that makes, so if we could come up with the right way to implement that, it will be a very effective way. And especially for example, for the kids who had this specific, for example, disability or all these thing, and then that might help a lot. So
thanks. I also offer another suggestion, and I think here universities do play an important role. All right, because I would say universities really have enough people who actually understands and know how to use these tools, and also knows what are the problems with these tools. All right, and the first group of people to train will be our teachers in primary and secondary school, because you can't stop the students from using it. You can't stop the students from using it. These AI tools are so accessible. All right, even I think the younger kids will now know that, well, there's a ChatGPT that can help them write essays. And teachers' response will be, well, is there a plagiarism checker that I can use, all right, to spot? But I think we know that there's a lot of false positive from all the plagiarism checkers. It's just that I don't think we know how to handle hallucinations coming from ChatGPT, and the like. So I think we can actually help to guide primary as well as secondary teachers on how to encourage their students to use it, but also at the same time highlight problems and issues and tools.
Right. Yeah, I agree. So for that, that is also exactly the things are coming to that model tuning and model verification thing. And then, so if we do the right, tuning of the models and also the frames for the use, and then that might be quite effective. So that, as you said, so university or higher education institution can take a major role for that.
Yeah.
And I would just simply add that we also need to change our
please.
assessment regimes. So I think assessment regimes have to change radically, so that AI tools could be used as part of the teaching and learning experience, and still we are able to assess what students are actually learning and what they're capable of learning by themselves. So not just teaching and learning has to change, but our evaluation, both formative and summative evaluation systems, have to change.
Yep. Well, we have a few more minutes, and perhaps now I can ask our participants to perhaps summarize quickly one or two thoughts that we want our participants to take back with. And to assure participants, we may not be able to answer all your questions, but I think we'll try to refer you to some of the places where you can actually find perhaps partial answers or answers. And we'll also be happy to share our presentations online on our website. So can I invite Teruo to just give 1 or 2 minutes on takeaway points?
Yes. So it's so for me it was so interesting to discuss on this topic and find out a kind of coherence with the this humans to be more human concept, and also my experiential learning concept, and this tacit coupling of tacit explicit knowledge. So that was the quite important point that we need to be address. We need to address in this very very much a rapidly changing situation in teaching and learning. So thank you so much.
Thank you, Teruo. I think I fully agree with you. I think that coupling, how to address that coupling, right, throughout the learning process is extremely important. All right, Pascal.
I think I cannot say better than what Professor FUJII just said, but I guess to emphasize the need to the fact that skills will be replaced by machines, but humanity will not be. So we need to come down to our core of being human, ethical human beings, and to work with machines of the future.
Thank you. Well said. Thank you. And Manu, over to you.
Well, thank you again it was lovely to be part of this panel. Again, all that's been said. I'm glad the explicit tacit coupling has caught on a little bit. I just want to assure people that in the field that I am, learning sciences, there are ways of embodying that and carrying that out, implementing that in curricula and teaching and learning that have shown to be effective. So I encourage you to look at that. The only other point I would make is that, one takeaway could be that personalization has to be very carefully designed. It has a promise, but hyper-personalization is problematic as well. So thank you.
Well, thank you. And thank you, I think, to our lovely participants. I'm sorry that you have asked a lot of questions, more than 22 of them, and we couldn't answer all of them given our limited time. But I hope that this panel, one a learning scientist, one an AI expert, and another an institutional leader, would give you a very good sense on the 3 different perspectives on how we view AI tools, all right? And I'm sure there will be lots more conversation. And thank you very much. We look forward to having you in our next DAU session, all right? And have a nice day ahead. Thank you, and thank you, panel members. Thank you, Teruo, Pascal, and Manu. And
thank you so much.
Max as well. Thank you.
Thank you.
Thank you, everyone.
Bye-bye.